Hello everyone, welcome to the lecture series on computer graphic 2D shearing. At the end of this session, students will be able to define 2D shearing, represent 2D shearing matrix, solve problem based on 2D shearing in computer graphic. In the previous lecture, we have seen several transformations. In this video lecture, I will be discussing about two-dimensional shearing in computer graphic, how to represent a shearing matrix, and finally conclude by solving some practice problem based on 2D shearing. Transformation is a process of modifying and repositioning objects in the existing graphic. When the transformation takes place on a two-dimensional plane, it is called as 2D transformation, whereas when it takes place in a three-dimensional plane, it is called as 3D transformation. Transformation in computer graphics are broadly categorized as translation, rotation, scaling, reflection, and shear. In this video lecture, we will be discussing about 2D shearing. In 2D shearing, shearing is an ideal technique to change the shape of an existing object in a two-dimensional plane. In a two-dimensional plane, the object size can be changed along x direction as well as y direction. So, there are two versions of shearing, that is, shearing in x direction and shearing in y direction. We will see each of them in detail. So, consider a point object O has to be sheared in a 2D plane. Let the initial coordinate of object O be x old and y old. Shearing parameter towards x direction is represented as shx, whereas shearing parameter towards y direction is equal to shy. So, the new coordinates of the object O after shearing are x new and y new. As you can see in the diagram, this is the original object. When we apply shearing in x direction by using the following shearing equation, here the change in the original object is observed only in the x direction. You can see over here x new is equal to x old plus shearing x into y old. Y new is equal to y old. There is no change in the y coordinate. As you can see, the original object is a square. When shearing transformation is applied in x direction, you see a slant in the object. The matrix form of the above shearing equation can be represented as x new y new is equal to 1. As the shearing is in x direction, we have shx 0 1 into x old y old. This is the shearing matrix in x direction. Now we see the shearing in y direction. Shearing in y axis is achieved by using the following shearing equation. X new is equal to x old. Here the x dimensions do not get changed, whereas you can see here with respect to the original object, the object after y shear is changed. There is a change in the new y, okay, the old y and the new y. So the new y, that is y new, is equal to y old plus shy into x old. Okay, so in the matrix form, we have the above shearing equation that can be represented as x new y new is equal to 1 0 shy 1 into x old y old. This is the shearing matrix in y direction. Now we can represent this matrix in homogeneous coordinate. For your understanding, I have represented the shearing matrix in y-axis in a homogeneous representation using 3 by 3 matrix. This is represented as x new y new 1 is equal to 1 shy 0 0 1 0 0 0 1 into x old y old and 1. The same can be applied for x-axis, only the change here will be sx, here it will be shy. Okay, now that you have understood the concept of shearing and the representation of shearing in x-axis and y-axis as shown in this matrix form, we will now solve a practice problem based on 2D shearing. Now, given a triangle with points 1, 1, 0, 0, 1, 0, apply shear parameter 2 on x-axis and 2 on y-axis and find out the new coordinate of the object. So I hope that you have got the problem. We are given a triangle, 3 points, and we have to apply the shear parameter using x-axis with 2 units and y-axis using 2 units. So let's solve this using a stepwise approach. So the old corner coordinates of the triangle are A 1 1, B 0 0, C 0 1. So shearing parameter towards x direction, that is SHX is equal to 2. Shearing parameter towards y direction SHY is equal to 2. Now for coordinates 1, 1, we have the new coordinates after shearing x new y new is equal to x new is equal to x old plus shx into y old, that is 1 plus 2 into 1. Because 2 is the shearing in x direction, we get answer 3 and y old remains the same. Thus the new coordinates of corner A after shearing are 3, 1. Now for the next coordinate of the triangle B 0, 0. So after applying the shearing equation, we have x new is equal to 0 and y new is equal to 0. Thus the new coordinates of corner B after shearing are 0, 0. Moving ahead towards the coordinate C of the triangle, where you have x new, y new using the equation, that is x old plus shx into y old, that is 1 plus 2 into 0 is equal to 1 and y new is equal to y old. Thus we can see that the new coordinates after applying the shearing in x direction for the given triangle are A is equal to 3, 1, B 0, 0, C 1, 0. Now we are done with the shearing using x-axis. Okay, now we see for shearing the same problem in y-axis. Here also the shearing unit that is being given is 2 units. So applying the new coordinates for corner A after shearing, we have x new is equal to x old, that is 1, and y new is equal to y old plus shy into x old, that is 1 into 2, 1. 1 plus 2 into 1 is equal to 3. Thus the new shearing coordinates for corner A after shearing are 1, 3. Moving ahead for corner B, we apply the shearing in y-axis. So we have the coordinates x new is equal to 0 by applying the formula, and y new is equal to y old plus shy into x old, that is 0 into 2, 0 plus 2 into 0 is equal to 0. That is the new coordinates for corner B after shearing are 0, 0. And for the last coordinate C, 0, we have the new coordinates after applying shearing in y-axis, we have 1, 2. Now you can see the new coordinates of the triangle after applying shearing in y-axis 1, 3, 0, 0 and 1, 3. So for this given triangle ABC, you can see the new coordinates shearing in x-axis and you can see shearing in y-axis. You can see 1, 3 over here. You can see B 0, 0 and C 1, 2. Okay, so these are the shearing applied in x-axis and shearing applied in y-axis. I hope that you have understood the concept of two-dimensional shearing in x-axis and y-axis, how to represent a shearing matrix in the normal form and also in the homogeneous form, and you have got an idea of solving and applying the matrix equation to a given graphics primitive. Now, I request the students to pause the video for some time and answer and solve the given problem. Here, a given triangle with points 1, 1, 0, 0 and 1, 0. Find out the new coordinates of the object along x and y axis, applying shear parameter 4 on x axis and 1 on y axis. So I request dear students, you pause the video over here for some time and solve the given problem using the matrix equations that we have learned. On applying the matrix equation, okay, we get the new coordinates for the triangle, that is a dash b dash c dash, as 5 comma 0 0 comma 0 1 comma 0 along the x-axis, whereas along the y-axis, where the shearing factor was 1, we get the coordinates a dash is equal to 1 comma 2, b dash is equal to 0 comma 0, c dash is equal to 1 comma 1. I hope you have got an understanding of two-dimensional shearing. These are the references. Thank you for your patient listening.